Welcome to Mina Academy. Over the course of this series of videos, we hope to explain every aspect of Mina Protocol, from how Mina nodes work, to creating a wallet, through to staking with validators and understanding ZK apps. If you're brand new to Mina, here's a brief introduction to its technology. Mina Protocol is a Layer 1 blockchain, but what makes it different to other Layer 1s is its use of recursive zero-knowledge proofs. These proofs provide near full node security for under 22 kilobytes, which, as people like to say, is about the same size as a couple of tweets. In this video we will explain the consensus algorithm used by Mina Protocol, essentially the way the blockchain network participants agree on a state of ledger. Mina uses a modified version of the Ouroboros Consensus Protocol, which was designed by IOHK. First we will look at how Ouroboros works, and later at the enhancements which Mina adds to create its own version, named Ouroboros Samasika. Due to the distributed nature of blockchains, all participating entities must synchronize and agree on which is the correct state of the ledger. In Mina Protocol there are three types of nodes. Number 1. Block producer or validator nodes. As the name suggests, these are the nodes that produce blocks, and only these nodes participate in the consensus of the network. Number 2. Archive nodes. An archive node is a regular Mina daemon connected to a running archive process. The daemon will regularly send blockchain data to the archive to store. From these, all the history of the Mina blockchain can be found. And finally, light client nodes. Once implemented, these nodes will only use a zero-knowledge proof to sync up to the network. These light client nodes also have the ability to run inside a web browser. Ouroboros is a proof-of-stake protocol and relies on all block producers committing a stake, rather than with proof-of-work protocols like Bitcoin that require solving an increasingly difficult mathematical puzzle. As a result, the environmental impact of proof-of-stake protocols is much lower. Also, instead of having an open election, proof-of-stake systems have a rota to decide which block producers will create the next block. The type of consensus algorithm Mina implements allows nodes to agree upon the state of the network and stake Mina to increase their chance of being selected as the next block producer. This is done first by requiring all block producers to signal that they are interested in creating a block by committing assets into the blockchain. The stake then fairly selects the leader to add the next block based on their total staked amount plus a verifiable random function. This randomness enhances the security of the blockchain. Ouroboros works on the premises that all participants have a synchronized time. For simplicity, let's imagine they all have synchronized watches. Time is split into slots. A number of slots together form an epoch. In each slot, one block can be added to the chain. Thus, slot 1 on one node is the same as slot 1 on another node, and it's the same for epochs. An epoch in Mina is around 14 days in length, and each epoch has 7,140 slots, and each slot is approximately 3 minutes long. There can be slots where there are no leaders, hence that slot may go empty. In the simplified example shown, this might be the number of blocks produced per block producer per epoch. But wait, what about the random function? Once this is added, the block distribution could look like this. This is just an estimate. Each block producer knows which slot they will be creating a block in at the start of the epoch. Thus the schedule could look as follows, but in reality it could actually look like this. As we see in the image, slots 2, 6, 10 and 12, no block producer has been elected to create a block. And in slots 5, 7 and 11, more than one block producer has been selected. The block producer leader election is held locally and privately, and a block producer can prove they are elected leader to create a block in a particular slot while publishing a block. At the same time, this information is not available to other block producers or viewers at the start of the epoch. This adds security to the network, as with a leadership schedule, nodes could be attacked. The chain could appear as shown, as more blocks are added on top of previous ones. This concludes our first Mina Protocol video. Next time we will look at some of the protocol parameters and attacks. Make sure you click to subscribe and ring the bell to get notifications of our new videos. You can also find this information on Medium. Check the description below for the link. Thanks for watching.